numbers, what do I do?
Add them together and divide by 6.
Yeah, so the average in this case is going to be 1 plus 2 plus 5 plus 9 plus 12 plus 13 all over 6. If I were to generalize that to a set of like n things, the average of a set is going to be the sum of the elements over the what? Divided by what? Yes, exactly, Jen. Number of elements. Exactly. So in this case, the sum, I think it's 42, and there's 6 of them. So what's the average? 7. We've added up all of the things in the set, and we've divided by the things in the set. We've added up all the things. So what were those things? Those things were, I'm going to do this visually. We had 1 and 2 and 5. Do it in graph form. We had 9, 12, and 13. So we had 1, 2, 5, 9, 12, and 13. So what did we do? I'm doing these with number lines here. What did we do with all those number lines? We added them together, and then we divided by the number of things that are there, divided them by 6. Let's say I asked you this right here. Suppose you go 100 miles in 2 hours. You go 100 miles in 2 hours. What's your average velocity? If you go 100 miles in 2 hours, what's your average velocity?
50 miles per hour.
Yeah, so 100 miles, 2 hours is going to be 50 miles per hour. Does this statement give us the velocity graph function? Does this tell us what the velocity function is? Do you see the velocity function anywhere in there? We don't know. We just know you went 100 miles in 2 hours. You could go really slow and then really fast, or really fast and then really slow. We don't know the velocity function. In this case, the velocity function is just something we don't know. But what does 100 miles represent in relation to the velocity function? What is the link between 100 miles and this velocity function that we don't know? What's the relationship between velocity and displacement? We figured that we've talked about this last class. What's the relationship between velocity and displacement? This is the velocity, which we don't know. I'm generalizing it here. Where's the 100? Where is the 100? This right here adds up to what? 100. The area under the curve is 100. And then if we wanted the average value, what did we divide the 100 by? What did we divide the 100 by? We divided it by what? 2. We divided it by 2, which was the time, the total time, the total time. So what is the way to represent that red area, Lizzie? That's the area under the curve. What's that mathematical symbol that we use? What did we call it? So this is the integral of v of t. We know that the integral of v of t dt is equal to what? From like, let's say 0 to 2. We know that the area under the curve from 0 to 2 is going to be what? Is 100. We know that the distance, the displacement from 0 to 2 is 100. What did we divide the 100 by? 2. Another way to write that would be 1 over 2 minus 0. Dividing by 2 is the same thing as multiplying by what? 1/2. Now here's the thing. Does it say from time equals 0 to time equals 2 on that on that question? It just says for 2 hours. It says for 2 hours. So I'm going to make this a little more general and say it started at time A. What's 2 hours from time A? What's 2 hours? What'd you say? A plus 2. And instead of saying 2 minus 0, what can I say? A plus 2 minus what? Minus A. So here's the thing. This question, I just generalized this. This question just told us that this right here is equal to what? 100, right? That thing right there is equal to 100. But what is this equal to right here? What's that equal to? What's A plus 2 minus A? What's A plus 2 minus A? 2. Oh, look. This is the generalized form of what we did. Did we get 50? Did we get 50? We did. The point is, this function right here, we don't know what the function is. It gave us the area under the curve. Is it always going to give us the area under the curve? No. Instead of giving us the area under the curve, it might give us a function and limits. Look at the next question here. It says, given v of t is equal to t squared plus 1 f of feet per second, find your average velocity from 0 to 5. So to find the average velocity, we first need to find the area under the curve. So what's the function this time? T squared plus 1. So we want to write, Nick, the integral of what? The integral of what, Nick? From 0 to 5 of what? Yes, so that's the area under the curve, right? Yeah. And what do we want to divide it by? We want to average it out, right? So we want to do what? Not a half. It's 0 to 5 now, so it's going to be 1 over. Yeah, so I'm going to do the super general, 1 over 5 minus 0. Because do you have to start at time equals 0? No, you could start at time equals 7, right? But in this case, it's time equals 0 to time equals 5. What these represent, this represents the end time. And what does the 0 represent? The start time. Now, on this one, what are you going to have to use to find the exact definite integral? What are you going to need to use to find the exact definite integral? Right now, use your calculator to find me, so you know it's 1 over 5 times, find me that, and then find the exact answer. I want the exact answer. Fn int, and then it's going to be y1, comma x, comma 0, comma 5, and that's going to give you that number right there. Then you multiply it by 1/5 to get the final answer. You need to be able to do that quickly, or it's going to be very hard for you to complete the next quizzes and tests. And it's going to be, if it's velocity, what is it going to be? Feet per second, right. Feet per second. The way you can think about this is this right here, you see this right here, everybody? That's displacement, right? So that's a measurement of distance. So what are the units on that one going to be? What are the units on that one going to be? Distance in this question is measured what? Feet. The distance is measured in feet. This is time, right? You're dividing by time. And in this case, it's seconds. So you've gone 46.6 feet in terms of displacement in 5 seconds. So what are the final units going to be? Feet per what? Second. 9. This whole thing is 9. Are you with me on there? So to find the average value, what do you have to divide that 9 by if you're going to find the average value? You divide 9 by what? If you want the average value from 0 to 4, you need to divide the 9 by what? 4 minus 0 divided by 4. So how high is that? So what did we say the average value therefore is going to be? 9 over 4 minus 0 is 9 over 4. What is 9 over 4 about? Not about. What is 9 over 4? 2 and what? 2 1/4. It's right here. So if I draw this all the way to here and go down, what can you tell me about the area of this rectangle right there? What's the area of that rectangle? What is the area of that rectangle? 9. The area of that rectangle is 9. We have drawn a rectangle that has the base on the time range, but what's the area of that rectangle? The same as the area underneath the... No. 2 1/4. 2 1/4 times 4 is 9. Yeah. So we have just drawn a rectangle with the same area as the area under the function, the curve, the area under the function. We have found a rectangle with the same base, but we've turned it, it has the same area as the area underneath the curve. Now, what's nice about this function right here? What type of function is this? This function right here, what type of function is it? It's a really nice piecewise function because it's all lines, right? The method we just used can be used for any type of function. So for example, here is the function we looked at before. We had t squared plus 1. We had t squared plus 1. So what does this represent? This is the area underneath the curve, right? What area does this rectangle have in comparison to this area? It has the this area compared to this area. What are they? They're the same. That's the whole point of this exercise. We are finding the area, we are finding a rectangle that has the same area as the area underneath the curve. What did we need to calculate this exact area? What did we need? We needed you needed a calculator. The example I just did with you, did you need a calculator? No, but in this case, you needed it, and then what did you divide by? You divided by 5. How tall is this? The height of this rectangle is the average value. The height of this rectangle is the average value. We found it. Do you remember what it is? It's less than 10. It was 9 and a... It's like 9 and a third. It's like 9 and a third. So the height of this rectangle is the average value. If you can't find the integral by hand, what can you use? Your calculator. If I give you a calculator on a quiz or a test, use your calculator to calculate the definite integral. A definite integral has a specific start and a specific end. So if I say integrate this from 0 to 5, that is me asking you to calculate a definite integral. The way I look at it, the way I've always thought about this in my head, imagine if this diagram right here, you see the blue highlighted, the piecewise function? The way I think about it in my head, I think of it as that boundary is made out of plastic. You can bend it, but you can't stretch it. So what do? You staple it to 0 and you staple it to 4, and then what do you do with this? You pull it out, and then what would you get? You would get this rectangle right here. If the area never changes, imagine it's the same area no matter what, you would make this rectangle right here. Does that make sense, everybody? You would make that rectangle. You're looking for the same area as under the curve. If you can't do it by hand, because you don't have too many ways to do integrals by hand right now, right? They better be lines, or maybe a circle, or you can't do it without a calculator. But what can your calculator calculate? Any definite integral you want. As long as you can type it into y1, you can always use the fn integration function on your calculator. On the AP test, actually, there's only 2 things you need to know how to use your calculator. Let's say, theoretically, it could look really complicated. It could be like, okay, here's a function. It's super complicated, right? And you're going from time equals, let's say, a to time equals b. So you have this function right here. It's f of x. How do you find the average value? You first find the what? You first find the area under the curve from a to b. So that's going to be the integral from a to b of f of x dx. And then what do you divide it by? 1 over b minus a. That's the average value of f of x from a to b. You're going to do that all the time. Does it matter what the function looks like as long as you can type it into your calculator? Not at all. Your calculator doesn't care. As long as you can type it in properly and punch the right buttons, your calculator will integrate these things quite nicely for you.